Okay, we began solving exponential equations that require a logarithm. You know that they require a logarithm when you can't think of the base to a power that equals what you're looking for. So, like, if I have 5 to what power equals 125, I know that's 3, because 5 times 5 times 5 is 125. But there is no integer power that I can take this to. 5 to the x power equals 72. There's no integer power. So when that happens, what I need to do is I need to do a logarithm. And so if you recall, we rewrite as a logarithm by doing this. If you remember with the lesson that we had a few days ago, where we do log base 5 of 125 equals x, and then you can honestly put that in your calculator and it will give it to you. So that's what we're doing here, is we rewrite this as a logarithm. Log base 5 of 72 is equal to x, and then we just put into our calculator log base 5 of 72 using that button, that little trusty button on our calculator that I told you about the other day. When you turn it on, and it's located right there. It's that button on the calculator. And I know that you can't see what it's doing. There it is. You see what it's doing, and then you just put the numbers in and hit equals. Okay. And this one, same thing. We just rewrite it as a logarithm, log base 7 of 80, and we put it into our calculator, and I've rounded it to 2 places. Now, they get more involved, and so I wrote out steps that can be done with any equation that requires a logarithm. If you see right here, I said add or subtract if possible. You don't always have that step to do. Multiply or divide if possible. And we'll get to some where we do these. Well, this one has an add or subtract if possible step. And then rewrite it as a logarithm, and then solve the resulting equation using your calculator. All right, so because this one has minus 6 on the side, we're going to move this 6 over here. So we're going to do what we've done with all equations in the past. If this was just x minus 6 equals 5, you all would know what to do. So we do it the same way. We add 6 to both sides, and we get 8 to the 3x plus 2 power equals 11. Now I can rewrite it as a logarithm. It looks a little bit different because the exponent is an algebraic expression, so it throws you off a little bit. But you just do this. It's still the same procedure. You just make that loop. Log base 8 of 11 is equal to 3x plus 2. Now, I don't typically put in log base 8, 11 here because and find the answer, because it would round my answer too much for down here. So what I do is I leave it there, and then I put it all in the calculator at one time when I get down here. But if you wanted to do that, you can, but you'd need to leave that number in your calculator and not round it so that you get a more accurate answer. So anyway, now that we have this, we solve like any other equation, and we subtract 2 from each side. Now, this 2 cannot go up underneath this because it's not like terms. So anyway, we have log base 8, 11 minus 2, and then we were going to divide by 3. So what I would do is I put this entire thing in the calculator, and I use the fraction button. So log base 8 of 11 minus 2 divided by 3, which is negative 0.28. All right, same, it's just another problem that's exactly the same. We are going to, and I kept the steps over here. You want to add or subtract, so we subtracted 4, that gives us 4. We rewrite it as a logarithm because there just isn't anything to multiply or divide by here, so we rewrite it as a logarithm, log base 2 of 4. Now you could write this one in because it's an integer, that's 2, but I left it alone like I did the other one. And then you add 1 to both sides, and so you take this and put this in your calculator. 2 plus 1 is 3. Log base 2 of 4 is 2. 2 plus 1 is 3 over 7, so your answer is 3/7. This one is the same thing. It's a natural log. It's just a log to base e. We have an e here. E is kind of like pi. Pi is 3.14159, blah, 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 blah. And this is 2.718, blee, blah, blee, blah, blee. And so the reason I say that is it just goes on forever. So we're going to use a natural logarithm button. That's going to be the only thing that's different. We also have a number here where the logarithm is being, the base is being multiplied by 6. And so we are going to use this step on this one where we hadn't used it on the others. All right, but subtract your 8, that gives us 12. Then we have 6 base e to the 0.25 x power. We divide by 6 to put it over here, that gives us 2. And now we have it in a way where we can write it as a logarithm. So we have log base e, and log base e is just natural log. Natural log just means that it's a logarithm taken to base e. And so natural log 2 divided by the 0 equals 0.25x, and then you divide by the 0.25, and that gives us 2.77. Same thing on this one, subtract the 2, that gives us 3, and then we're going to divide by this 3. We're going to divide by, that's going to give us 1. Then we have natural log 1, and natural log 1 is 0, but beside the point, natural log 1, then when we rewrote it, natural log 1 equals 0.5, then divide it by 0.5, and our answer is 0. But you do them all the same way. You add or subtract if it's possible to do so. You multiply or divide if it's possible to do so, and there will be a number in front of the base. That's how you'll know. Rewrite as a logarithm, whatever, this one's natural log, and then solve it by using your calculator. Thank you.